Hello everyone, welcome back to my channel. So in today's video, we are going to discuss admission controller. What if you could guide your Kubernetes API request as per your wish and not just block them, but actually change them on your fly before they even hit your cluster, before they get registered inside your etcd. Sounds like magic, right? So yeah, that's what we will be seeing in today's video, like what exactly the admission controller is and how it can unlock a whole new level of power for policy enforcement and your cluster management. That's what we are going to see. Let me open a paint and then I will show you so far what we have seen just to set the agenda. Okay, so far what we have seen is we have this kubectl utility which we are using to instruct our server to create our resources, right? Then it will go to Kube API server, where Kube API server will be responsible for your authentication and then authorization, and then finally it gonna hit your etcd. That's what we have seen so far, right? So let me write it is, let's say, your authentication, and this is your authorization, and finally this is your etcd database where the all object and all the resources information gets stored. So far we have seen that if you want to extend the access of your cluster, right, so you can allow access to your users, to your group, and we have seen that in our security video where we discussed our RBAC, our SSL based certificate authentication, how you can down, and then once that certificate or maybe the another mechanism, let's say RBAC, you are assigning to your user, they are able to log into that particular cluster, right? So that is something that yes, we can control who can log in and what they can do. What if you want a further extension? What if you want to enforce a policy according to your environment? What if you want to comply to your environment, right? Let's say maybe you are running a very high sensitive environment, right? And you don't want to developer that they can use a image from the public registry, right? Because so far what we have seen is, let me go back to our notes. See, a user who is allowed to log into server, right? And if he has some cluster role and cluster role binding to create, get list, update, delete pod, or maybe any other resources, right? He can do. He can create a pod because he is already allowed that. He has a role and role is binded to that particular thing, actions, right? He can do, he can log in and he can create that pod. That's what he can do. But here we cannot control, right? Like I cannot control that he cannot use a image from the public registry. I cannot enforce that, okay, every time when you are going to do, you need to put a label called application equal to dev, right? And maybe there are much more scenarios which you want to put inside your resources. So that thing we cannot achieve with the help of RBAC or maybe the certification cluster role and cluster role binding, or maybe a simple role and simple role binding, right? Only permits images from a certain registry, maybe your internal, not public. Your or maybe on public, let's say you have already assigned only one of the QA.io, let's say. So these things you cannot do with the RBAC. If you want to, you do not want that particular pod can run as a root user. You do not want to enable such certain capabilities. You want a pod always has labels or maybe a default labels. So all these things we can do with the help of something called admission controller. So now the question is, where is the admission controller, right? We haven't discussed that, and we haven't seen in this picture also, like how can uh, I would say that I can say that, okay, you have this and you can go and you can do that, right? Because the flow goes like this, right? Flow is going like this. Now, once you are running a kubectl, so kubectl automatically checking that whether what is the mechanism, whether you are using a certificate or RBAC and that, right? That request will go to a Kube API server and Kube API server will check your authentication. If you are allowed to log in, he will allow. Then the next step will be authorization, where it will allow you to create or take action against any object, right? We have taken example of this pod, right? A user can create a pod if he is allowed, right? So here you can see that he can authenticate, he can authorize, and obviously he can create its pod. And now what will happen is, the pod will get registered into the etcd. But now the question is, what if I want to put this policy? I want a label, right? Because I cannot control these things here. So that is why here comes is your admission controller. Admission controller sits between your Kube API server and your etcd. So this thing is your admission controller. I would write AC. So that is the AC we have understood. Okay, what AC is, which we can create a policy, which we can create kind of compliance stuff, or maybe any other restrictions or a kind of policy foundation you want to impose on these resources. So what it will do is, it will gonna hit your environment, right? Hit your request before it reaches to etcd, before it reaches to your actual cluster, right? So what AC can do is, AC can allow, AC can deny. So AC is nothing, AC is an admission controller, and based on that, it can allow and it can deny your request. Though a user is allowed to create a pod, right? He can create a pod, but I have my admission controller sitting between my cluster and the authorization and authentication and authorization, where I have imposed a policy that whatever you are doing, right? If your requirement, if your pod manifest file or any that whatever you want to put doesn't have these label called app equal to dev, deny that request. So see, that is the magic. User is happy. Okay, I can authenticate, I can authorization, and I have the policy, I have the roles, I can create a pod. No, you still control. This is a kind of the boundaries you can set. Okay, still he is able to get in, but this is the only thing he can do with the all these policies, right? So that's what the admission controller is. Now the question is, how we can define the admission controller? Is it an inbuilt admission controller, or is it a custom admission controller, or if we need to define some, how we can do it, right? So that's what our next topic is. So all these things can be done via admission controller to secure your cluster. That's what we have understood. Apart from validating the request, it can perform additional operation like modifying or validating, right? Why? Let me tell you. Let's say you have put a policy. You have two policy. One policy is like, whenever a user is defining a image URL, if it is not belonging to my internal, deny it, right? Second policy says, if a user is forgot or if he is not putting any label, right, apply this default label to each and every pod inside a namespace. That is something called mutating. So admission controller is a two type. One is something called validation and the other one is something called mutating. So validation will just validate, like I have mentioned, this image, right? Image you have done here. What you have done is it will gonna kind of make sure that okay, you are using which one? You are using a particular image which we have done. If you are not, deny it. If your request is not having a particular code, then what you need to do is you need to mutate, you need to modify that request and apply these default labels across my infra so that I can track, right? So that's what that you can put and you can allow and deny, right? So now next thing is there are pre-built admission controller, right? And which are, some are by default enabled and some are by default disabled. But is it your choice? You can still go and enable these pre-built admission controller. Hold on, we will see that how you can do it. But you can see that always pull images. Yeah, that is something which one? That is something admission controller. You can control it, right? You can say always, never, not available, like that. So that you are kind of putting a validating. If it is not, it will gonna pull the image. Default storage class, if not specified any, add this default PVC. That is also kind of mutating admission controller. Event rate limit, like at a time how many APIs can go to your API server, right? So that it will not get frustrated or maybe overloaded. Namespace exist. Whether a namespace is exist, then do, otherwise default. It is enabled by default. You can see these are not enabled by default. Namespace auto provision will create the namespace if doesn't exist, not enabled by default, right? I will show you. Let's say I want to run. Yeah, this is the same machine. I just logged in from this VS Code terminal. Okay, kubectl. Let's say run nginx dash dash image equal to nginx, and I would say hyphen n cloud. So what you can do is error from server not found, namespace cloud not found. See, enabled by default. Why? Reject request if namespace doesn't exist. Whereas a different admission controller is namespace auto provision. If you would have enabled this, what will happen? It will first gonna create this cloud namespace, and then within that namespace it will gonna create this nginx image, right? As the name suggests, namespace auto provision, right? That's we can see. Next will be how you can list all the enabled controller. So if you are running your dedicated service for your Cube API server, you can directly go and you can just list it, right? But we are running our Cube API as a pod. I will show you. It will be in your Cube system environment. You can see I have this Cube API server, right? So how you can go and check this detail? Let me copy this command and I will gonna shoot it. Okay, the name is this one, the full name you need to provide. So let me just correct the name of our pod where I just want to execute this command. Uh, Let me fix this here and then I will copy paste. That's better. It is copied and let's see now. So here you can see this command has given me some output, right? So admission control string, that is different thing, but I just want to see this enabled admin plugins, right? These are the plugin which I just want to see. Okay, what are those and how they can do it. So admissions is divided into two phases. The first phase is mutating admission plugin run, and the second phase is only validating admission plugin run. What this line mean is, we have discussed these two policies, right? The second policy we have discussed, where we have mentioned if any resource is not having these labels defined, then what will happen is your policy, your admission controller will mutate your request and add these labels as a default in your request. So just try to understand the flow here. What will happen is, first it will gonna validate your request, right? First it will gonna validate whether your manifest file or your request is having that default labels or not. If not, then it will gonna mutate. So always validation will be happening first, and the second is mutating. So that's the flow for this admission controller, and that's what they are saying is, right? So here you can see that there are few. The name in the below list may represent a validated plugin. This. All these are that uh, inbuilt admission controller. But in the second thing, you can see admission plugin that should be enabled in the addition to the default enabled one are these one. These are the default one which you can enabled, right? So if I just want to show you, let's say I want to add this namespace, or maybe I just want to add that we have seen that, right? Namespace auto provision. So if you want to enable this, how you gonna enable this? You need to change the what? You need to change this Cube API server configuration, right? And how you can specify? You can specify with the enable admission plugin flag, and you can put that whatever you want to enable it. If you want to disable, which is already enabled, you can see that these are the inbuilt enabled admission controller. And if you want to disable these, how you can do? You can put like this, and it will gonna disable this. So what we will do is, we will gonna enable this namespace auto provision, and we will run that same command with the cloud which we have run. Let me run that command again. It is failing, right? So now what we will do is, I will go to etc kubernetes manifest file, and here we have our this cube API server, right? Let me go to the putty so that we will see a big screen. Kubernetes manifest, and here you can see you have something called cube API server, and you can see that these are the commands already there, and you can see that node restrictions which is already enable. By default it is not enabled, but explicitly in this installation it was enabled, right? And what is we need to enable? We need to enable this one. I will copy only this, and I will just put inside our cube API manifest file, and we'll see how it will gonna behave. Okay, before I save, let me clear my screen, and I just want to see this cube, or I would say API, because when we do some changes in this, right? So what will happen is, it will gonna uh, get ports hyphen, it is API server. Okay, so there was a typo in the grep command. It will gonna restart your API server, so that we will see. As of now it is running, right? It is running since 52 days. Okay, Now if I go and I have made the entries and I will gonna save it, right? Now let's see. Because until unless it will not restart, right? So how come Cube API server will know, okay, there is a change in the default enabled admission controller. That's what we have seen, right? After the admission controller and before reaching to the etcd, it must go via admission controller, so that it will know, okay, there is a new admission controller is added inside that particular thing. Okay. Okay, yeah, it will take time, as I mentioned that it will gonna restart that Cube API server, and if it is restarting the Cube API server, that is expected that you will lose your connection to your API server because it will gonna restart it. So that's what we are doing, and I'm waiting for that, and then we'll gonna run that cloud command. It's pending. Now it's running. It's up and running, but it is not yet ready, so we need to still wait. Now it is ready, it's completely ready. I will gonna cancel it. I will gonna see it one more time. Yes, we are good. Now let's run that cloud, and this time you can see there was no namespace cloud, right? With this what will happen is it will gonna validate that whether a particular namespace is there or not, because I am explicitly saying create a pod inside a cloud namespace, but there was no namespace. So what it has done is it has mutated the environment, it has mutated my request, and first it has created a cloud, and then it has created a nginx inside that deployment, right? Let me show you one more time. As of now you can see that there is no test environment, right? Let me create a test namespace, and then we'll see that with the same command, right? I'm gonna just do it, and we'll see, okay, if it is creating or not. And here you can see that there was no namespace, but still it my request got created. Why? Because it has created a test namespace first, and then it has created a nginx, right? So that is the validation. If not, then it will gonna mutate. But not all admission controller are acting as a both actions, right? There are few which acts only as a validator. There are few which can act as a mutator. But mutator is something, obviously first it will go via validator and then only it can mutate something, right? So let's try to understand that. So there are validation controller which validates the configuration and allow or deny your request, like namespace exists, which we have just seen, right? Earlier it was enabled, but now we have overridden with what? We have overridden with namespace auto provision. If no namespace, then it can reject the namespace, and that's what it was doing. Resource quota, if there is no resource available, obviously it will gonna reject your request. Namespace lifecycle, right? That is also going to validate. Let's say if you want to delete, try to delete k delete namespace, let's say this public one, because these are the locked uh, namespace. You can see, right? Although I am running my command as a full admin privilege, but still it is saying forbidden namespace queue public is forbidden. The namespace may not be deleted. Why? Because it is locked due to this namespace lifecycle validation controller. Because it is validating your request before it is hitting to your cluster, like what exactly you are trying to do. Similarly, we have something called mutating controller. So what mutating controller does is which validates the configuration and can change the configuration in order to succeed. That's what we have seen. We have enabled a namespace auto provision which is validating whether a particular namespace is there or not. If it is not, then it will gonna change means it will gonna mutate, it will gonna modify that request. First it has created the namespace and then it has created a resource inside that. There are few which can mutate, like default storage class. If you have set a default storage class for any of the storage class, and if you're trying to do any PVC or PV, right? And if you are not specifying a particular storage class which from where you want your PV or PVC to be created, by default, this will get assigned and your PV will be allocated from that default storage class. Default toleration seconds, default ingress class. So all these are mutating controller, right? There are many more. If you want, you can do what? You can go with the official documentation and look for all these admission controller, what exactly those are and how they are behaving. I have just taken few examples just to understand this topic, like how it works, what is admission controller and all these. Now, there are few which acting as a both mutating and validating, like limit range, always pull image, service account, right? That's what we have seen. Like service account. In one of the video, we have seen that if you are not specifying any of the, let's say if I just describe a pod called Nginx inside a namespace called test. So here you can see what happen is service account default. So by default, this admission controller is in action now. It is validating whether you are explicitly allowing any of the service account or denying any of the service account. If you are not denying, then obviously there will be a service account by default. And if you are not specifying which service account to be created or maybe mounted inside your board, then by default a default service account is there in each namespace that will be allocated to this particular thing. Okay, so that is something that it's doing. Uh, what happened? Why these are not come up? Okay, there is something wrong with the node one. I will check, but let me delete this k delete ns test, and I will delete that. Okay, it has rebooted, so we need to wait to come up. Meanwhile, we will delete that cloud namespace as well. Okay, so now these were the inbuilt admission controller which we have seen. But what if there is something which I want to uh, impose, which I want to put as a restriction, and I want that thing to be in action, right? So what you can do is you can write your own admission controller, whether in Go language or whether in something called Python. Okay, so for that we will see how we can do, but there are a kind of third party already available in the market which you can go and you can deploy and you can get the access. Usually they called is policy engine, like they have that OPA gatekeeper, Kyverno is there, right? Maybe many more which you can go and you can I haven't worked on these, so I just got this information from the documentation, so that's what I just put here. But yeah, we can do these things, right? Maybe on some other day I will try with the Kyverno or maybe the gatekeeper how you can impose your own. But what I have done is I have gone ahead, I have written one Python script, and using that Python script, I am checking my resource request if they don't have that default namespace. Based on that, what will happen is it will gonna validate my request, rejecting that request and mutating that request. Right? So that is the demo we will see. So please be in video with me. Now, what is that custom logic can be, right? Board must have some environment and team information level like validating. If it is default label, you can put like it can mutate, only permit image from certain registry, do not permit run it. All these things we have discussed, right? So these things we have seen. So what I have done is, these are also kind of user defined when you say that custom controller, right? So what they usually call it, mutating webhook server, validating webhook server, or maybe webhook admission controller. What is webhook? Webhook is nothing. Webhook is a kind of trigger which is on some event based, right? Like you have seen in your pipeline also. If you are just pushing something to GitHub, then your code will be automatically start building your application, right? Maybe Jenkins if you are running, so it will automatically sense, okay, there is something new pushed to the code. Now I can go and I can run this thing, right? So we have that mutating admission controller which first validate your request, and if it is not according to the policy which you have set, what will it will do is it will mutate your request. And the validation is something which will just validate. If it is not there, simply it will gonna reject that request. If it is there, it will gonna allow that request, right? So let me explain you what is the demo is, and then we will see in action. So what I have done is, let me see if that node is come up or not. Otherwise, I will pause the video and I will restart that machine, and then I will come back. Mm, Okay, I am back. So you can see that there was some issue with the node. I have rebooted and now it is up and running. Okay, I was explaining this demo, right? So what I have done is, let me take you, our file is called validation webhook server. So as I mentioned, I have created a Python script. I have built that image and pushed to my Docker Hub. What that image is doing is, that image will gonna check whether a particular pod is having a label called app equal to dev or not. If that pod is requested with the label called app equal to dev, then that request will gonna allow. Otherwise, my webhook server, which is a validation webhook server, will gonna deny that request. So this is just a deployment which we are doing with that image, that Python script image. You can say that the policy which I have created, and I have exposing this with the service on these ports, right? But in order to take to your action, right, it's not something that you have just deployed your webhook server and you are done. No, it is same like any other deployment, right? Until unless how your Cube API server will gonna call this webhook server, right? Your policy will not be in action. So in order to do that, what we need to do is we need to create something called validating webhook configuration. And what it is doing is, we are just creating a webhook. These are the rules I am putting, like I'm putting in any API group. This one, any action operation is create for the resource called ports, then this webhook policy will be applied. And how this webhook configuration call my deployment? Remember, we have exposed that as a service. So here you can see I am calling that my webhook server. Webhook is something that which you can call, or it can automatically sense if there is some events. So the same thing we are doing here. If any of the pod request create request is there, and if that, then it must go via this, where we have put the restriction that if a particular pod is not having a label called app equal to dev, then definitely it will gonna reject it, right? That's what we are doing. And in order to do that, we need to give a CA bundle. CA bundle is nothing. Again, you need to create some certificate, and you need to create this, and you need to bound that, so that this request will have a full privilege to take the actions. That's what we are doing. Once that is done, I have this validate pod demo.yaml file, where what we are doing is we are just creating a two pod. One is, you can see that valid pod, right? And I am putting a label called app equal to dev. This will be approved by the this webhook. Another pod I am creating a call invalid pod, where I am just putting a label, but it is not dev. It is, the value is prod. So that is why this pod will get rejected by this webhook validate admission controller. Okay. Whereas the second scenario is where I am creating a same thing, right? But in this Python script, what I have done is I have put another function which is just adding that value. If that particular pod is not having that label called app equal to dev, that particular thing will gonna go via this webhook, and this webhook will validate first, and if it is not, then it will gonna put that particular key and value, that label, and then it will gonna create my request. Same thing, in order to call this deployment, I have exposed this as a service called Mutation Webhook SVC, and for this also we have a configuration called mutating webhook configuration. Earlier was validating webhook configuration, but this is a mutating valid webhook configuration. Same thing, I'm doing this also on the creation of pod action. This is the service which call my webhook, and this is the privilege I am giving to this one, right? So that is the scenario. Then we're gonna create a pod called where we don't put any label, and my mutate webhook server will gonna allow this with the modification, and the modification will be, it will gonna add a label called app equal to dev. So that's what the scenario is. Hope you guys are understood. But before that, what we need to do is, you need to, because that whatever just now I have discussed, right, that is already there. You can go and you can read also, like what exactly we are doing, what our image is doing, if we are putting that any of this YAML file, what all this YAML file will gonna create. So in order to get that particular CA bundle, we need to create our what? We need to create our key and certificate, and then we'll create a secret called where we will bind this uh, certificate, right? Let's come to our server now, and let's go to our CKA labs. Let me see if it is already, yeah, we are good. Let me just take it left. So it is creating a TLS key and certificate. That's done. So we have something called TLS key and CRT is there. What is the next command? Next command, we just need to create a secret called validate webhook TLS cert. Okay, TLS is created. Now the next command is just to get that certificate in the something called base 64 encoded format. That's also done. Now copy this, and it is asking us to update this in validate webhook configuration, right? We discussed. So because we need to give this privilege to our that, so it is file called 62, yes, and okay, it is already there, so let me just remove it. Delete it, and I will put the new one which we just created. I think it was already there, but anyways, we just created, then I will put the new one. Okay, so it is done now. What next? Once the set and key are created, secure as secret, then deploy the webhook server as deployment. So I will gonna deploy my validation webhook server using my own Python based image, right? We need to wait for our pod to come up. because it needs to pull that image and then it needs to create the container. Okay, once that is run, then we need to create this configuration for the validation webhook. Okay, it is up and running. Good. Now create our validation webhook configuration. Once it is created, we can verify. Okay, so to verify, like other object, we have command kubectl get and then the object name. Similarly, we have here as well kubectl get validation webhook configuration, and here you can see it has created a one validate, something called pod label validate validation. Name always must be in a descriptive format so that you can understand, okay, what exactly that particular thing is doing, right? So that is a recommendation. Whenever you are doing something, just put a name to be descriptive. Okay, now it is saying create a sample pod now to validate the webhook. So we have discussed this file 62-3 where we were saying create a valid pod and invalid pod. Why invalid? Because it is having a different label. It is not wrong, right? But we have a policy like each and every object must have a label called app equal to dev. Okay, now let's try to create it. And here you can see that's what I was expecting. Valid pod was created. Why? Because it has passed its validation. Validation was label must be app equal to dev. But the second pod, which is invalid pod, was not able to pass the validation because it has a different label. And what it is saying is error from the when creating this admission webhook. You can see that our webhook is in action now. This is the webhook which we have created, denied the request. Why? It is rejected. All pod must have label called app equal to dev. Now it is understood, right? If I'll go change this and then I will try, it will allow this pod as well. That is why this description must be in a understandable format so that now people who don't know, okay, what exactly that particular webhook is doing, so that it can understand and will act as that way, right? So that was the thing for this. You can see now I have a two pod running. One is the validate webhook and the other one is valid pod, right? That is for the second thing, demo, which is a mutating webhook. We need to create a separate key because we need to call it as via different service. So I will gonna create a different key, and for that we need to create a dedicated secret as well. Now if I just say k get secrets, so you can see that I have one is validate webhook TLS secret, which was just created 5 minutes before, and we were checking that how it can validate our request. And this is the mutate webhook which we just now created for our second demo. Now again you need to update that bundle in the mutating webhook configuration. So let's see what is that. Now let's copy, and it is asking me to update in this mutating webhook configuration file. I will go inside this and I will just change this CA bundle. It is pasted now. I will go save this. What next? Now we need to create a deployment for the mutating webhook server. And that is again coming from our same Python script, not same but same repo. We have a different Python script which validating your request as well as mutating if it is not passing that checkpoint. Okay, so now it has created. If I see, so it must be up and running. Let's see. Okay, let me see the deployment. It should come, or maybe the resource crunch. Maybe let's try to do one thing. Let's delete the validating this one, okay? Or maybe let's just describe why it is not coming. We'll see something. Mutation webhook, okay. It is failed to create, but it is not showing me anything like why it has failed. Let me see if I can see something in events. Okay, the last event was the from the webhook, mutation webhook, error creating admission webhook. Okay, see why? That is the reason, right? Because now what we are doing is we are creating, and this is our validation webhook is in action, and that is the reason it is not able to create our webhook, right? Because this is the, if I'll show you this one. So here I don't have that app equal to dev label for my this, right? You can see that there is no app equal to dev. What I will do is I will not delete that, but we will add this label app equal to dev inside our pod. So k get deploy, k edit deploy. I will go inside this, and where is the, here it is. I will say app equal to dev, but this we need to change because you cannot keep the same key. Okay, and I will just save it. Okay, it will not allow. Maybe we need to reinforce. Yes, what we need to do is we need to replace with the force command, and I need to apply this. So let's see whether it will gonna allow or not. It does not match template label. Okay, we forgot something probably. Okay, it was deleted, but okay. Anyways, I will just go and do this stuff again. Not this one, the deployment file, which is 63-1, and this is the, yes, we need to change the selector as well, and I need to change this to app equal to dev and change the selector, and okay, and we need to do the same thing inside our service as well. I hope we are good now. Let's quickly create this. Okay, the service was already there, so let me delete it first because I want service to be created with the new label. Now it has created. Now let's see if it is creating. You can see that mutation is now created. Why? Because it has passed our validation. Now it has a, if I just show you, k describe pod, and if you go this, you can see it has a new label called app equal to dev, and that is the reason it has passed that validation webhook and it is allowed this pod to be created. Right? Now it is done. Now we need to create a mutating webhook configuration, and that is in 63-2, I believe. Yes, it has created now. Now we have that pod, right? Which is saying if a particular pod is not having that label, whether that will be allowed or not. Let's say mutate pod. I will go and I will quickly create this file, and you can see it has created. There was no rejection. If I just show you, and you can see that mutate pod is up and running. If we will gonna describe this, you will find what? You will find a label called app equal to dev. And from where this came from? This came from where? It came from our mutation admission controller, because in the manifest file you can see we don't have any labels, right? But when the pod is created, it went via mutation webhook, which validates whether a particular request is having this default label or not. If not, then mutation will be in action and it will gonna add that particular label, whatever or whatever that particular thing you want to achieve, right? So that's what a admission controller is, and you can create a many admission controller, or you can uh, deploy it outside of your cluster, which we discussed, like that gatekeeper or maybe Kaivarna you can deploy, right? Maybe on some other day I will create some video on that as well. But yeah, this is something that the custom controller which you can write with your own hands within your own environment, right? You can use a Golang, you can use a Python script, anything which can just get the information in JSON format and check that validation and modify it if it is required. You can build that code and you can run that as a deployment, which is I am running validation and webhook, right? And post that whatever you are doing, that will go. So this is the surprise for me as well, right? Because once I have created this webhook, right, I didn't think that okay, this mutation will got failed. Why? Because this is already in place. Now each and every request will go via that validation webhook, and it was failed. Why? Because this was not having that app equal to dev, right? Maybe I will change the order in nodes, or maybe I will update the label inside this deployment file. And how we find? So that you can also check whenever you feel that okay, there is something which is not working or running, always check for the logs, always try to describe that thing, always check the events. So here you can see that when we were checking the events, what we found is we found our this one. Why? Why it was failed? It was clearly saying error creating admission webhook. Why? Because it was denied by our validation webhook. Rejected. All ports must have label app dev. So it is clearly understood, right? And we just quickly fixed it, and now we are in action. We have both our webhook and running, right? Now if you try to create that invalid also, right? Which was I think 62-3, right? Already exist. Okay, it was already there, but it is admission webhook is this. Okay, it was still going through that. It is denying that particular thing. It is not creating that because it is having a label, a different label. That is why. If I just simply remove that label, because it is just checking only for one label, and that must be this. Either it is not, if it is there, it must be. Let me quickly delete it, and now if I create it, it must be allowed. You can see invalid pod created. It was already there, that is why it is crying, but now you can see invalid pod is created, because the condition is it is having a one label and which is app equal to dev. But there was a app equal to prod, that is why again it got failed. But now I completely remove it and then I have created it. Now it went via validation, it rejected, then it went via mutation where it has added that particular thing. And how you can find? You can just simply describe this, and there you will find a label called app equal to dev, right? So that was the admission controller. What are the all inbuilt admission controller? What are all custom controller you can create? What are all the ways you can do, and how you can take this in action, right? If also you want to do this, then you can just simply check these file, like where I am just exposing my image. It is at this path. You can go and you can fetch this, right? So that's it for the day, guys. I hope you understood what is admission controller and how it is a kind of additional security checkpoint after RBAC, right? Before hitting your ETCD. So it is good you have a further control post this. You can put a additional boundaries, right? That permission boundaries you can put. Okay. So yeah, I hope you found this helpful and you learned something new today. So I would request you to hit that like button, subscribe my channel and share it with your other friends or colleague who just wanted to start with the CKA, because this is the uh, CKA exam perspective course which we are doing in 2025. So in coming days, that Linux Foundation will give you some kind of huge discount on the exam booking, because today is the 25th of October in 2025, and maybe in coming 1 month you will see that there will be a huge discount. If you want, you can just, if you are following along with me, then it is good. You are already almost ready for your exam. There are only few topics left which we will just be uploading in coming days, and then we are good to go. Okay, so yeah, that's it for the day. Maybe in next class we will see that how what do you call that, auto scaling work inside a Kubernetes, which is something called vertical auto scaling and the horizontal auto scaling. All right, so I will meet you in the next video, guys. Thank you. Bye bye.